Hi all, welcome to Geeks for Geeks. My name is Nitin Kaplas. Let's talk about today's problem. Our problem name is minimum absolute difference in BST. Let's read the question first. Our question said we are given a BST having n nodes. Our task is to find the minimum absolute difference between any two nodes, right? So this is the example first. We are given a BST, right? And our output is 10. So in second case, we are given this as a binary tree, right? BST. Its answer is 20. Let's understand this question better. So if I take this example, before taking or implementing this answer, let's see what the question said. We are given a BST. So in BST, its property is root. All the value in the left side of the root is smaller, right? And all the value in the right side of the root is greater than root, right? So this is the simple property of BST, right? Now, our task is to find minimum difference, or said minimum absolute difference. Just think about it. We are given the nodes or a value of the BST, right? We need minimum absolute difference. So minimum absolute difference between any two nodes is that two nodes which are very close to each other, right? It simply means that, for example, here we have 20, right? If I do the difference with 20, for example, I do the difference with 80. What is 80 minus 20, which is 60? It's very high, right? If I do 20 difference with 50, 50 minus 20 is 30. But if I do difference with 20 now, just greater value. What is just greater value of 20? That is 30, right? Its difference is 10. So here, for example, let's take 30 here. If I do difference with 30, for example, with 80, so 80 minus 30 is 50. And let's do the difference with 70. Okay, let's take 70 here. 70 minus 30 is 40. It's very huge. But if I do the difference with 30, just greater value. What is just greater value? Is 50. So this is 20, right? So what I am trying to tell you that here we have to do the sorting. If I have the value in the sorted manner, it's very simple to calculate minimum difference, absolute difference between the two nodes, right? It's just greater value. We have just greater value in my sorting part. Let's do this. So suppose I am using a vector to storing that value, and just think about it in a BST. If I do which traversal I have to do so that I store that value as a sorting manner, right? We have to do the in order traversal, right? So in order simply tell us that go to the left side, first step, then we have a root itself. Third part is go to the right side of it. I just simply do these three steps, right? Let's make a vector here. This is my vector. I hope you know that how we can traversal this, right? So first step is right now I'm here. Okay, just go to the left, left, left. Now, right now, after going to the left side, I reach to this node, right? Again, I go to the left side. Now I reach to this node. Now, if I go to the left side, what I get? I get null value, right? So here I have to write that if root equals to null, I have to return in this case, right? Let's return. Now I'm here. Its left is over, right? Now it's time to store this value. 20 I am storing here. So after second step is over, I have to go to the right side. Now I am here. It's also again null. So base case tell us that return that value, right? Now this part is over, right? 30 ka left is over. Now again I am at second step. So which is 30? Just store this 30 here. Again, left is over. root is over, I have to go to the right side, which is null. Again I have to return. Now I'm reaching to this case. I am at 50. Again I am at second step, just store 50 here, right? Again in this case I am at this place, right? So in that case I again go to the left side of it. I have 60. This is null, just return it. I just store 60 here. Again I am reaching to 70 here and 80 here. So if you clearly see, this is in the sorted manner. Now I just do the simple step, which is for loop, and update my answer as v of I minus v of I minus 1, right? Just creating a for loop of it, which is I equal to 1, I less than n, I plus plus, right? So here I am just do this thing and storing this thing into my answer. Let's suppose here, which is minimum of answer, v of I minus v of I minus 1, right? At the end of it, I just return my answer. Okay, it's as simple as that. But if you see the constraint part, before seeing the constraint, let's check this time complexity and space complexity. So here my time complexity is just storing that node's value into the vector I have to traverse, which is big of n, right? Again, I have to check which is smallest difference between these two. Again, I have to do the for loop, which is big of n plus big of n, which is big of 2 into n, right? So again, we can say that it's big of n, but here I am using extra space, which is big of n, to storing the values of the nodes, right? But if you see the constraint, it's tell us that you have to use extra space as constant, right? Big of 1. How we can solve this? Just let's do the second solution here. So we can easily solve this second solution just using the first solution. In first solution, we are just taking all the values and storing into the vector. But here we are not storing that value into the vector. Instead of that, we just track the previous value, right? And here I am using previous value. So I just do the root data minus previous value, right? Minus previous value. So here simply words, I have to track of the previous value. Let's see how we can solve this. Let's take this as my binary tree. So in this case, as I tell you, I have to track the previous value. Let's create a previous value as minus e raised to 10 raised to power 9 and my answer as maximum, right? Now I am at 50, right? Let's write here 50. Again, we have to use the in order. So in order, tell me, go to the left side. Okay, right now I'm here. Again, go to the left side. Okay, I am here. Again, go to the left side. Now I am reaching to null. Just return it. Okay, let me write here. Let me write here the code as well. Okay, let me write here. So this is my function. Let's suppose this is my function. Okay, inside this function, first I go to the left side. Let me write here root left. Okay, now when I am reaching to null, let me write here base case if root equals to null. In this case we have to return. Okay, let me return. Now I'm returning. Now I'm reaching here. Okay, so if I am reaching here, I have to compute the minimum value. So let me check answer equal to minimum of answer or root data minus previous value. So what is your previous value right now, which is minus 10 raised to power 9? What is root, which is 20? If I do the computation, which is 10 raised to power this, it's approx 10 raised to power 9, right? but here answer is infinite. So I want minimum. Let me replace this with 10 raised to power 9. Okay. Now you have to go to the right side. Before going to the right side, I have to update my previous. Right now, my previous will become 20. Let me write here previous equal to root data. Okay. So when I go to the, now I am going to the right side, which is again null, I again return it, going to the base case. Okay. So here, let me write here, go to the right side. Now, when this is over, what is my previous value? Previous is 20. Let's replace this with 20. Okay. Now, when I am reaching here, this is my current, this is my root node, right? Again, I am at this line. Minimum of answer root minus previous, root data minus previous. What is root? 30. What is previous? 20. What's the difference between these two? 10. Update my answer. Let me update my answer and this will become 20. Okay. So answer will become 10, right? And what is my previous? Previous root become previous, right? So right now 30 is my previous. Let me write here 30. Okay. Now go to the right side. Okay. So this is null. Okay. This is null. So this is null. Return it. Now I am here, right? When I am here, what is my previous, which is 30? 50 minus 30 when I am here. 50 minus 30, which is 20, which is greater than answer. So I don't want to update my answer, right? Okay. Now go to the right side. What is my previous? First of all, I have to update my previous as well. Now previous will become 50. Let me update my previous, which is 50. Okay. Now I go to the right side. When I go to the right side, I encountered with 70, right? So again, I am reaching to this line. Go to the left side. Its left is 60. Let me write here 60. Okay. Let me write here 60. Now, again go to the left side. It's null, right? Return it. Now, this is my current root, right? This is my root. Root minus 50, which is 10. So it's as it is 10, right? After that, I have to update my previous. Previous will become 60, right? Again, go to the right side. When I go to the right side, it's null. Again, return it, right? When I am reaching to this case, this node, this is my root. Root minus previous, which is 10. Again, no need to update it, right? Again, I go to the right side. When I go to the right side, before going to the right side, I have to update my previous, which will become 70 in this case, right? When I go to the right side, its value is 80, right? When I am here, go to the left side, which is null, return it. Right now, my root is 80. 80 minus previous, which is 70. Again 10, no need to update it. Okay. After that, I go to the right side, which is null. Again I return it. So this function is completed. This is also completed. This is also completed. So in this case, what is my answer? It's 10. Just return this answer output, which is 10, right? So previous solution, we just store all the values, but here I just track the previous value, right? Hope you understand this. So what's the time complexity in this case? If you clearly see, we just reach every node once, right? So its complexity is big of n. And here we are not using any extra space like in previous we are using vector, right? So here my space is, if I neglect the recursion call stack, my space here is big of 1, right? Okay, I hope you understand this dry run. Let's code this now. Let's do the step by step. As I said, I use the previous variable as minus 10 is to power 9, right? And answer as a maximum, which is int max. Okay. Now I'm writing here helper function which pass root, previous variable and answer. Okay. Now let's write this function. So inside this function, I have to pass by reference because I want the updated value, right? So previous is also passed by reference and answer is also passed by reference. Now, first of all, I go to the left side. Let's write this first. So root left, previous and answer. Now when I'm at the ending of it, so I just encountered with root equals to null. Let's write the base case. Now when the left part is over, I have to compute it, my answer. Let's write here answer equal to min of answer root data minus previous. Okay. After that, I have to update my previous as my root. So previous here is root data. After that, I have to go right side. Now, when all the functions are over, at the end of it, I have to return my answer. Let's return answer here, right? So this is the simple code of it, right? Let's check it's working fine or not. Yeah, the compilation is good. Let's submit it. Yeah, as you see, all the cases are passed. Okay, hope you understand this question. Just do the dry run of this code. You simply like you can understand it very easily, right? So I hope you understand this. Thank you so much.